Good afternoon, everyone. It's an honor to have the opportunity of making this presentation. Today, I would like to present my paper, Haptic Force-Guided Sound Synthesis in Multi-Sensory Virtual Reality Simulation for Rigid and Fluid Interaction. Now, I will introduce our paper in the following 6 steps. First, as we all know, a multi-sensory VR system usually contains audio, visual, and haptic. And in this paper, we focus on audio. One core issue for sound synthesis for rigid and fluid interaction in multi-sensory VR simulation is how to balance the algorithm efficiency, result synchronization, and the result authenticity. This is due to the fluid motion exhibits long-time nonlinearities, which increase the difficulty of sound modeling and sound synchronization. Fortunately, Thrill et al. Stated that the vibro-tactile and acoustic phenomena share a common physical source. Based on such an idea, we analyze the relationship between audio and haptic, then propose a novel haptic force-guided granular sound synthesis method tailored for sounding in multi-sensory VR systems. Now I will introduce some most related works. First, in the multi-sensory VR simulation. Previous works mainly focus on rigid and rigid interaction. In 2013, Thrill et al. First proposed a rigid and a fluid interaction. They adopted approximate solutions to simplify the sound model for real-time rendering. However, this will lead to the absence of sound details and reduce the authenticity of the sound results. In sound synthesis method, there are several great physically based methods proposed for fluid sound simulation. These methods can generate realistic fluid sound. However, the synthesis time of these methods cannot achieve real-time requirement. So, on the other hand, non-physically based methods, especially the granular synthesis, these methods can generate realistic sound efficiently. However, these methods has an obvious drawback, unpredictable granulation. This will cause a synchronization between sound and animation. So, our goal is to find a controllable and efficient method. Now I will introduce the pipeline of our method. At each time step, the user inputs the rigid body position xt and the rotation angle theta t to the haptic device rendering module and the rigid and fluid simulation module. Then we can generate the haptic force as the input of the sound synthesis module. With the haptic force sequences and grains, we can generate the corresponding grain with multi-force granulation. Then the grain is transformed to the frequency domain through FFT, and after phase reconstruction and IFFT, we can get the time domain sound. Now I will introduce each part in detail. First, the input of the sound synthesis. Our rigid and fluid simulation is built on a SPH method. In SPH simulation, rigid and fluid are represented as particles. Here is a frame before rendering, and these are rigid particles and these are fluid particles. Here is a frame after rendering. Then we will calculate the haptic force. When a rigid particle comes in contact with fluid particles, that is, in the smoothing volume, then we can calculate the haptic force. The haptic force is a combination of 3 different forces: pressure, viscosity, and buoyancy. With these 3 different forces, we design a MF granulation to generate the corresponding grains. The physical process that generates sound during rigid and fluid interaction can be divided into 4 components. First, the in-detail high-frequency impact. Second, the final leap out. Third, the small bubble harmonics. And fourth, the moon cavity oscillation. After we divided the grains into 4 parts, we determine the position for the extracting grains. For example, when the buoyancy equals 0 at t-1 and is larger than 0 at time t, then we will set the position as the start of the impact sound. Then we will synthesize our final sound. Since in the VR application, the sound synthesis is a real-time feedback with user operations. Thus, it is impossible to hide artifacts through post-processing, such as smoothing envelopes. Therefore, we synthesize the final sound in the frequency domain. There are 2 main points needed to determine in the spectral granular synthesis. First, the grain size. The selection of the grain size is a trade-off between the efficiency of algorithm and the result quality. And we finally set 9,600 samples per grain through our experiment. Second, the phrase reconstruction. In our experiment, we use SPSI method to reconstruct our phrase and generate the final sound. Next, we will compare our methods with different state-of-the-art granular sound synthesis method. The teaming statistics is showing in the table. We can observe that also in our method, we add haptic force to get the sound synthesis. Our method can still achieve the real-time feedback. And next, we will show some results. Here is a result with the sound generated with the granular synthesis method. And please notice the synchronization performance of the sound. Can you hear the sound? We can observe that the sound cannot match the animation, and that is our result. We can observe that when the ball drop in and leap out, the sound is synchronized with the animation. And next, we will show a result with the sound synthesized by a physical-based method. This method simplifies the bubble sound model, so it reduces the authenticity of the sound result. And then we will show our sound synthesis by our method. Our result is a granular synthesis method which based on recordings, so it can achieve more realistic sound results. And next, we will show some other results. Here is 3 different results of balls with different densities. And first is a ball with a small density. This is a ball with middle density. So it's with large density. In summary, our paper proposes a new haptic force-guided sound synthesis method which can achieve higher quality with competitive time performance. And this is the first attempt to make the use of the haptic feedback in sound synthesis in the multisensory VR simulation. And thank you for listening.
Thank you very much for the talk. I'm just interested in whether your method is what you use the granular synthesis, right? So is it limited to certain type of sound, or is it dependent on the model being particle simulation based?
Oh yes, due to our method is a granular synthesis method is limited by the recordings. When the recordings is limited and our sound type is limited.